Hey, today we're going to talk about finding the surface area of a pyramid or a cone. And here are the three examples we're going to go through today. We have a square pyramid in the first one. So this is a square pyramid. We obviously have a cone here in the second, like an ice cream cone. And in the last one, we have another pyramid, and we have to count the number of sides here. 1, 2, 3, 4, 5, 6. So it's a hexagon for our base, so we call that a hexagonal pyramid. Oops. Let's roll this down so you can see it. There we go. So today we're going to be working on finding the surface area of these objects. So let's jump into the next slide here. Pyramids. So there's two different ways we can find there's two different types of areas we can find. We can find the lateral area, which is the sum of all of our faces that don't include the base. And we talked about this with prisms yesterday a little bit, but in pyramids, the lateral faces are always triangles. So if we're ever asked to find just the lateral area of a pyramid, we're just finding the area of those triangles. The surface area includes the entire lateral area and the base. Cones, on the other hand, are a little bit different. The shape of a cone, or at least what wraps around the circle, isn't a triangle. It isn't really anything in particular that's that's a shape that we know. It kind of looks like a circle, and it has a piece cut out of it, kind of like that, and it wraps together to make our cone. So to find the lateral area here, we actually do pi times r times L, where L stands for the slant height. And we're going to write down the formula for surface area of a cone on the next slide. It's actually really nice to have that formula. We don't have to worry about taking it apart like we do with the pyramids and finding each of the areas of each face. But once again, for cones, the surface area, just like with pyramids and with prisms and cylinders, we want to find the surface area. It's the lateral area plus the base. All right, so here's your MCA formula sheet. We do have the formula for cones here, and this should be added to your notes. This is the formula for the surface area of a cone. So pi times r times L, where L is the slant height, plus pi times r squared. So make sure you have that one in your notes. If you have to pause the video to write that down, that's fine. But let's go on to our first example here. So the first one says the base of our pyramid is a square, and we want to find the lateral area and the surface area. So go ahead and pause the video so you can sketch the picture of this square pyramid. All right, let's find the lateral area first. So I'm going to put LA here for lateral area. The lateral area is the area of each of those triangles. And since our base is a square, all of these sides along the bottom are 4 centimeters, which means all of my triangles are the same size. So what I like to do is just draw the triangles out here. There's 4 centimeters. And I can see here the height of my triangle. So I've got that perpendicular 90-degree angle here. The height of all my triangles is 7. So if I want to find the area of one of those triangles, I do 1/2 times base times height, which is 1/2 times 4 times 7. If I type these in my calculator, I get the area of one of those triangles to be 14. Remember that we have 4 of them, so we have to do 14 times 4, which gives us an area of 56 centimeters squared for those 4 triangles, which again is the lateral area. Now, if we want to find the surface area, we're going to take that 56, which was the area of those 4 triangles, and add it to the area of our base. And our base is a square, so we can do base times height, or it's really 4 times 4, because all our bases and heights are the same. So this ends up being 56 plus 16, which is just 72, and our units still are centimeters squared. So a quick one there for the surface area of a square pyramid. Go ahead and pause the video, sketch this one for yourself. We're going to find the lateral area and the surface area of this cone. All right, remember from our notes or from earlier in the slide here, when we talk about the lateral area of a cone, it's just pi RL. So I like to draw a cursive L there just so it doesn't look like a 1. But this piece right here is the lateral area for a cone. Now remember, L stands for the slant height. And if I look at the cone that we have right now, 14 represents the outside part, and this is considered the slant height here. So that's what we'll use for L. There are going to be examples with cones where we're going to actually know this height, so the actual height of the cone. And if that's the case, we would have to use Pythagorean theorem here with our radius and our slant height to figure out what that is. But like I said, in this case, we don't need that because we already know the slant height. So let me go back to pink here. Let's find the lateral area first. So our lateral area is just pi times r times L, which for this problem is pi times 5 times 14. And if we plug that in, 5 times 14 times pi, we get, let me round this to 1 decimal place, 219.9, and our units here would be meters squared. And so to find the surface area here, let me switch to red. The surface area, I'm going to use my formula here, which is pi RL plus pi r squared. And I know pi RL is 219.9, and pi r squared is pi times 5 squared, pi times 25. And so if I add those together, I get my surface area for this cone to be 298.4 meters squared. And that's it for the cone. Let's try our next one here. So here we're going to find the surface area of the cone, or excuse me, of the pyramid. And in this case, the base of our pyramid is a regular hexagon, so 6 sides. We want to find both the lateral area and the surface area. So let's do the lateral area first. Let me switch back to blue and go ahead and pause the video so you can draw this one yourself. Okay, let's do the lateral area. So we've got triangles here. We have a hexagon, so 6 sides, so it means we have 6 triangles. And like we did for that first pyramid, I like to draw my triangles out here. 20 is the height, and then I have 8 for the side length, which is the base of all those triangles. So the area of triangles, we've already done this before, 1/2 base times height. This is 1/2 times 8 times 20, which gives us 80 for the area of one of those triangles. And again, we have 6 of these, so we have to multiply by 6. 80 times 6 is 480, and our units would be inches squared. So there's the lateral height there for that pyramid. So let's find the surface area here, which means we need to add the lateral height with our base. We need to find the area of the hexagon. So the hexagon's formula is 1/2 SAN, or 1/2 A times the perimeter. I like SAN, the side length, the apothem, and the number of sides. Unfortunately for this one, we have the side length, we have the number of sides, but we don't have the apothem, so we have to figure out what that is. So let me pull the hexagon out here. Actually, I'm going to see if I can draw my triangle. So remember, from the center to the apothem, we can draw a triangle here. And what I know is that this side here is 4 inches. It's 1/2 of 8. Okay. And what I need to do is figure out what that angle is. So 4 inches. There's my apothem. I have to figure out what this angle is up here. Remember, we did this last week. We said we have 6 triangles inside of that hexagon. So I have to do 360 divided by 6, which tells me each of those triangles would have an angle that's 60 degrees. So 60, 60, 60 all the way around. And we cut that in half here. So I need to do 60 divided by 2. And the angle in my red triangle would be 30 degrees. So again, we're putting those pieces together here to try to figure out what our apothem is. So let me set up my equation here. I have my opposite side, that's 4, and my adjacent side is my apothem. So I'm going to use tangent. And tangent of 30 equals my opposite over adjacent, which is 4 over a. And in my class, we write this over 1, and then we cross multiply. So I have a times tangent 30 equals 4 times 1, which is just 4. And I'm close to solving for a. I have to, jumped in there. Last thing I have to do here to solve for a is get that tangent to the other side. So I want just a all by itself. So I have to divide by tan 30. So those cancel out. And I have 4 divided by tangent of 30. That gives me a equals 6.9. So that's my apothem. So I'm going to put that in my formula, 6.9. And now I want to multiply all of these together. So 1/2 times 8 times 6.9 times 6 gives me 165.6. And that is my area of the base. So the entire surface area here, is 480, the lateral area, plus 165.6. And when we add those two together, we get 645.6. And our units are inches squared. And there's our final answer. All right, let's try one more. A birthday party hat has a diameter of 12 inches and a height of 14 inches. How much paper is used to create the hat? So we're not including the bottom here. I will give you a second to pause this one and set it up in your notes. All right, so this is a cone. Our surface area equation for a cone is pi RL plus pi R squared. Now for this one, we're not including the bottom. The shape at the bottom of our birthday hat here is a circle. So what's not being included is the area of the circle, which is our pi R squared. So really for this one, we're just finding that lateral area. Our diameter is 12. So if our diameter is 12, that means our radius is half of that, so 6. And our height is 14. Whoops, too far there. And our height is 14, so right here, the height of that hat is 14. So let me get a different color because this isn't working as nicely as I thought. I was hoping the blue would show up better. So 14, and that one, and we need to find that slant height. So 6 was our radius, 14 is the height. We need to figure out what the slant height is here, so I'll put an L there. And we talked about how we do this on that last, or the first cone problem we have. We need to use Pythagorean theorem. A squared plus b squared equals c squared. So the hypotenuse is L, our slant height, so that's what we're trying to find. And we can put 6 squared and 14 squared in for A and B. So 6 squared is 36. 14 squared is 196. 36 plus 96 is 232. And remember, when we're solving for C, the last thing we always have to do is take the square root here to get rid of the squares. I'm going to switch back to red here. And if we take the square root of 232, we get C, our height, or excuse me, our lateral height, to be 15.2. So 15.2 goes in there. Probably should use blue to finish that one up. So if I do 15.2 times 6 and then multiply by pi, I get the value for my surface area, which is 200, or excuse me, I should say lateral area, but 286.5. And our units are inches squared. So a birthday hat here with a diameter of 12 inches and a height of 14 inches would use 286.5 square inches of paper. All right, the review assignment that you're going to work on after you finish your practice problems in Google Classroom is you're going to create a floor plan of your own apartment or house, or something that you'd like to create. It doesn't have to be your actual apartment or house. You can make up your own apartment or house. If you want to make it cool, you can do that. But the test is next week. You're going to need to find the area of each room of the house, find the perimeter of your entire house, and find the surface area of the walls of your house. So area, perimeter, and surface area. You want to make sure that your floor plan includes at least 5 rooms, and you have to use at least 3 different shapes for the room. So not every room can be a rectangle or a square. You have to be a little bit more creative when you're coming up with this picture. Okay. But that's what you're doing for your review. All that's going in Google Classroom. Good luck.